Here's another perturbation on the straightforward stoichiometry calculations. Limiting reactant means that when you run out of one of the ingredients, you can't make any more product. So how much will you get? If you know amounts of both reactants, how much product will you really get? For instance, suppose that we're making hamburgers. I have enough meat to make 5 hamburgers. I have enough buns to make 4. How many can I really put on the table? 4. Because when I run out of buns, I've run out of buns. Alright, so let me show you. This is really easier to show you than to tell you. Let's say that I'm going to react. Alright. Well, we see that we're being given amounts and asked for amounts, so once again, we're going to have to start with our balanced chemical equation. We know that we're going to react aluminum hydroxide with hydrochloric acid. We know that one product is going to be aluminum chloride, but they don't tell us what the other product is going to be. Well, this is a double replacement reaction, a compound plus a compound. We've got the aluminum chloride, so now we're going to have the hydrogen hydroxide, which is our old friend, water. Alright, is it balanced? 1 aluminum, 1 aluminum. 3 hydroxides, 1 hydroxide. So we'll have to increase that to 3. 1 hydrogen that is not hydroxide, 3 hydrogens that are not hydroxide. We're going to have to increase that, which is good because that then gives us 3 chlorines, 3 chlorines, and there we go. Alright, we know that we have 15 grams of this stuff, and we know that we have 15 grams of this stuff, and we want to know how much of this stuff we have. Uh-oh. Well, remember the things that we know the amount of we're going to call A, and the stuff we want to know the amount of we're going to call B. Oh, crud. We have 2 A's. That is what makes this a limiting reactant problem. We know 2 amounts, and we don't know which one we're going to run out of first and stop the reaction. Alright, so I'm going to call this A1 and A2, just so we can tell them apart. And the secret is very simple. I'm going to do the stoichiometry twice. Once with A1 and once with A2. And whichever one gives me the less amount of product is the one that will really happen. So let's start with 15 grams of A1. We want to get out of grams of A1 and into moles. Well, we need the molar mass here, so let's see. Aluminum, if I'm not mistaken, is 27, and oxygen is 16, but there's 3 of them, so that's 48. Hydrogen is 1, but there's 3 of them, so that's 3. So that will give me 78 grams to the mole. Alright, now we're out of grams of A1. Alright, now we look at the coefficients of the balanced chemical equation, and we see that we're going to form 1 mole of B every time we use up 1 mole of A1. Alright, our moles of A1 will cancel. And now we are ready to get out of moles of B and into grams of B. Now we need a molar mass again. Alright, aluminum, we're going to say, is still 27. Chlorine is about 35-ish. So with 2 sig figs, we'll just say that's 105 because there are 3 chlorines. And so that will give us 132 grams to the mole. I really ought to make sure I have a periodic table handy before I start doing these things. Alright, I let my fingers do the walking on the calculator, and you guys probably don't recognize the advertisement that I'm referencing there at all. Alright, I've got 15 divided by 78 times 1 divided by 1 times 132. This predicts that I'm going to make 25 grams of B.
Canalla, por vos es gente pobre.
Well, maybe. I'll make 25 grams of B if I use up every bit of my aluminum hydroxide, if that's the one that runs out first. But maybe it's not. Maybe this one's going to run out first. Let's try it and see. We know we have 15 grams of A2. All right, we want to get out of grams of A2 and into moles of A2. All right, we need a quick calculation of molar mass here. But if we're saying that chlorine's 35 and a hydrogen makes it 36, so that's pretty painless. Now we're out of grams of A2. We look at our balanced chemical equation and see that we'll make 1 mole of B every time we use up 3 moles of hydrochloric acid. That gets us out of moles of A2. And now we already figured out that the molar mass of B is 132. So 132 grams of B for every 1 mole of B. And now we are ready to do our calculation. Clear out the old one. We have 15 divided by 36 divided by 3 times 132, and that predicts that we're going to make 18 grams of substance B, which is our aluminum chloride. Well, this is the real world. If we have a choice between making 25 grams and 18 grams, what are we going to get? 18 grams. It's always going to be the least amount possible. Just like with our hamburgers, we had enough meat for 5 burgers, we had enough buns for 4. 4 it is. And so that will be my final answer. You just do the stoichiometry calculation twice and choose the one that's smaller. How do you recognize that this is a limiting reactant problem? Because you have 2 known quantities. That's not it. Not bad. We can do this.